Now, here is one problem. Find the distance of a point -1, -5, 10 from the point of intersection of the line r bar is equal to 2i minus j plus 2k plus lambda into 3i plus 4j plus 2k and the plane r bar dot I minus j plus k is equal to 5. Now, here one plane, this is one plane and one line is like this. Let it be the point of intersection of the line with the plane. Okay. Now, and the point -1, -5, -10 is somewhere here. This is the point -1, -5 and 10. Now, we have to find the distance of the point from point of intersection of line and the plane. Suppose if we find this point P, then we can determine the distance between them. Now, to find the point of intersection of the line and plane, we have to consider the Cartesian equation of the line in the form of x minus x1 by a1 is equal to y minus y1 by b1 is equal to z minus z1 by c1. Now, see here, given line is r bar dot r bar is equal to 2i minus a plus 2k plus lambda into 3i plus 4j plus 2k. Now, this is the vector equation of the line passing through this point and parallel to this vector. R bar is equal to a bar plus some scalar into b bar form. That means, this is the vector equation of a line passing through this one and parallel to this vector. Now, I am going to change this vector equation into Cartesian form. The Cartesian form is x minus x1 2 by a, that is 3, is equal to y minus y1, here it is minus 1, therefore minus of minus plus 1 by 4 is equal to z minus, where z1 is equal to 2 by 2. Now, this is the Cartesian equation of the line. Now, let it be some value lambda. Of course, here lambda is already used, no? So that let it be some constant k. Now, from here x is equal to 3k plus 2 and y is equal to 4k minus 1, z is equal to 2k plus 2. Now, let P x, y, z be the point of intersection of the line with the plane. What is that? R bar dot I minus a plus k is equal to 5. Now, we can substitute this point in this line. You know, here the line equation is in Cartesian form and plane equation is in vector form. So that we try to make this vector equation of the plane into the Cartesian form. The Cartesian form of the plane is, what is that? To convert into Cartesian form, we have to consider r bar as a general vector xi plus yj plus zk. Now, substitute and apply dot product there. Right now, it changes to x minus y plus z is equal to 5. Now, the point P is point of intersection of line and the plane, hence the point should be on the plane. Therefore, the point P x, where x is equal to 3k plus 2 comma y 4k minus 1 comma 2k plus 2 lies on the plane, the point of intersection lies on the plane x minus y plus z is equal to 5. Now substitute this point on the line. Now let us continue here. Now substituting this point, therefore 3k plus 2 minus of y is equal to 4k minus 1 plus 2k plus 2 is equal to 5. Now here it is 3k plus 2k, 5k minus 4k plus k, and it is 2 plus 1, 3. It is 2 plus 1, 3, 3 plus 2, 5. 5 is equal to 5 gets cancelled, k is equal to 0. Hence, the point P is 3k plus 1, that is 2, 4k minus 1, 2k plus 2 is equal to 2. Substituting k is equal to 0. Now is point of intersection of line with the plane, and the given point is minus 1, minus 5, minus 10. Okay. Now let us find the distance between them. Here the distance of this point from this point is equal to the distance between them. The distance between them is equal to 2 plus 1 whole square plus minus 1 plus 5 whole square plus 2 plus 10 whole square under root. And therefore, it is 3 square 9, 5 minus 1 4 16, and 12 square 144 under root. Now what is this? It is 114 plus 144 plus 16, 160 plus 9, 169, 13 units. Therefore, the distance of the given point from the point of intersection of line and plane is 13 units. Now this is one more problem. Prove that if a plane has the intercepts A, B, C on the coordinate axis. Here a plane has the intercepts A, B, C on the coordinate axis and is at a distance of p units from origin. Then 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by p square. Now the plane is at p units distance from origin, as well as it makes intercepts on the coordinate axis. Now let us take the diagram. X axis, its y axis, z axis, and a plane makes intercept A units on x axis and b units on y axis and c units on z axis. Let the plane be like this. Now this is the origin. From origin the plane is at p units distance. Okay. Right now let us find the equation of the plane first. You know, the x-intercept is a units. Hence, the point of intersection on the x-axis is a 0, 0. Now the plane cut the y-axis at b units distance. That means it is 0, b 0. Since the intercept on z-axis is c, then the point on z-axis is 0, 0, C. Therefore, the plane has intercepts A, B, C on the coordinate axis. On the axis X, Y, Z respectively. Now, equation of the plane is can we determine the equation of the plane when it passes through 3 points? Yes, that is determinant of, we have the determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. Now this is the equation of the plane passing through 3 given points x1, y1, z1, x2, y2, z2, x3, y3, z3. Now here the 3 points are a0, 0, 0b, 0, 0, 0. Now substitute them. Then the equation become x minus, where x1 is equal to a, y minus 0, z minus 0. Next, x2, y2, z2, 0 minus a, b minus 0, b, 0 minus 0, x3 minus x1, 0 minus a, 0 minus 0, 0, and c minus 0, c. Therefore, the determinant of x minus a, y, z, and this is minus a, b, 0, minus a, 0, c is equal to 0. Now expand the determinant. Expanding the determinant. After expanding the determinant, we get the equation of the plane in Cartesian form. Now the equation is x minus a into, deleting the corresponding row and column, that is BC minus 0 minus y into minus AC plus z into plus AB is equal to 0. Therefore, it is x BC plus y AC plus z AB. This is minus ABC, move to right side, plus ABC. Now dividing by ABC on both sides. While dividing by ABC on both sides, now it become x BC by ABC, that means x by A, y AC by ABC, y by B, z AB by ABC, z by C is equal to ABC by ABC1. Therefore, this is the equation of the plane whose intercepts are ABC on the coordinate axis is x by A plus y by B plus z by C is equal to 1. Now, this is also known as intercept form of the plane. When we have the 3 intercepts on the coordinate axis, then you can directly consider this equation. X by A plus y by B plus z by C is equal to 1. Now, this plane is at p units distance from origin. Now, this plane is at p units distance from origin. Therefore, the perpendicular distance from origin to the plane is equal to p. But what is the perpendicular distance from origin to the plane? That is, the perpendicular distance from origin to the plane is equal to modulus of d, where d is equal to 1 by root of 1 by a square plus 1 by b square plus 1 by c square. You know, when the equation is of the form ax plus by plus cz is equal to d, then the perpendicular distance from origin is equal to modulus of d by root of a square plus b square plus c square. It is already proved. So that using that formula, we can write the perpendicular distance from origin to the plane is equal to 1 by root of 1 by a square plus 1 by b square plus 1 by c square. But the perpendicular distance, it is given that p. So that this value is equal to p. Now on cross multiplying, 1 by p is equal to root of 1 by a square plus 1 by b square plus 1 by c square. Now squaring on both sides, 1 by p square is equal to right side square root eliminates while squaring. Hence it is 1 by a square plus 1 by b square plus 1 by c square. So finally 1 by a square plus 1 by b square plus 1 by c square is equals to 1 by p square.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.